This time on Battle Factory, a helmet that's easy to wear and tough enough to take a bullet. A pocket-sized icon that's been lighting up the fight since World War II. A mobile filling station that fuels the front lines. And a simulated explosive that trains the mind for war. Battle Factory steps beyond the front lines into top secret factories where combat gear is built for battle. When these delicate snowflake shapes are pressed together, they'll form a piece of headgear that's comfortable enough to wear to war and tough enough to take a bullet. On October 3rd, 1993, a squad of U.S. Special Forces rappelled out of two Black Hawk helicopters onto the streets of Mogadishu, Somalia, in an attempt to seize two enemy lieutenants. The operation went south when the Somalis shot down the choppers and stranded the forces in an overnight standoff that inspired the movie Black Hawk Down. The Special Forces ops were willing to risk injury or worse rather than wear the uncomfortable Army-issue helmets that blocked their vision and messed with the communication system. So instead, they wore hockey helmets to the firefight. U.S. casualties were high. A plan was put into effect to design a helmet that soldiers could wear that would protect them in situations like the Mogadishu standoff. By the time troops shipped out to Iraq, the Special Ops helmet had been transformed into a ballistic helmet with mobility, visibility, and comfort. The Special Operations Delta helmet breaks down into two parts: the attachments and the body. The helmet is made from a synthetic plastic material called aramid. Sheets of the material are rolled out onto a cutting table and stacked on top of one another. It's the layering that makes the helmet anti-ballistic or bulletproof. Fibers are so tightly woven that the projectile gets caught in the web and expends a lot of energy trying to push through. More layers means more protection. Patterns are laid over the aramid sheets and cut with a bandsaw. The operator wears a chainmail glove to make sure he only slices through the material. The aramid is cut and piled into snowflake-shaped stacks. The stacks are rolled over to the press. Individual sheets are laid onto a mold in an overlapping pattern. Steamed heat and 150 tons of pressure fuse the layers together to form the helmet shell. Paint won't stick to aramid, so once the shell is complete, an additional paintable layer is pressed on to form the outer surface. The helmet is hand-trimmed to remove the excess material. Holes are drilled for chin straps and rails for mounting optical gear. Up until the mid-90s, helmets hadn't evolved that far from the steel doughboy helmets of World War I. In Mogadishu, Special Forces were more likely to wear cloth caps than to be weighed down with a helmet that offered little in the way of real ballistic protection. When they did wear helmets, they were likely to be $40 adjustable hockey helmets to protect them from banging their heads, not stopping a bullet. So a helmet had to be developed that offered the same comfort as a hockey helmet, with the ballistic protection and utility of combat gear. One helmet from each batch is tested by simulating a worst-case scenario: a bullet to the head. A helmet is positioned 5 meters from an automated 9mm rifle. The rifle is loaded and fired. A bullet travels at almost 440 meters a second, directly into the helmet. And while it does damage to the outer shell, it doesn't pierce it, which means in combat, it just saved a soldier's life. Once the batch has passed the ballistics test, the helmets are trimmed and a rubber edging is applied. Now the helmets are ready for painting. Once the paint is dry, the helmet gets a camouflage coating using a process called Hydrographics. The 5-color print comes on a film, which is cut to size and placed on the water surface. A chemical spray both dissolves the film and activates a bonding agent. The helmet is dipped into the vat through the print, which floats on the surface like an oil slick. The pattern sticks to the helmet, then a top coat seals in the design. The inside of the helmet is fitted with an adjustable harness, neck pad, and shock absorber inserts. The outside of the helmet is kitted with rails to mount tactical equipment like lights, gas mask, communication equipment, and night vision. All the comforts of a $40 hockey helmet with the necessities of modern warfare. So wearing it shouldn't be an option. It's just using your head. Coming up on Battle Factory, it didn't just light fuses and heat rations. This wartime legend even stopped a bullet. And these portable containers carry enough fuel to power an army. These ribbons of solid brass will get pressed into service as an icon that's known by its look, its sound, and its name, the Zippo. When the U.S. entered World War II, Zippo started building their lighters exclusively for the U.S. military. On the front line and in the foxholes, GIs found comfort in a battlefield smoke. From World War II through Vietnam, Zippos have played their part in the war effort to light fuses, hammer nails, and heat rations in a helmet. There's even a story that a Zippo, sitting in a shirt pocket, saved a GI's life by stopping a Viet Cong bullet. The Zippo lighter breaks down into the insert, which houses the fuel tank, and the outer case. To make the outer case, 1-ton coils of pure brass are spooled out to a stamping machine, where 60 tons of pressure produce the lighter bottom. Then, a hinge and the 2 halves of the outer case are slid into welding braces on a moving table. Next, an electrode welds the hinges to the case. The flip-top case is what gives the Zippo its distinctive sound. The cases are loaded onto hanger frames and primed for their chrome plate finish. First with a nickel bath, and then with a cleaning solution. Zippo has a long tradition of specialty engraving, which makes the lighter highly collectible. But some of the most sought-after Zippos are those personalized by the servicemen themselves. Called trench art, soldiers would engrave their names and messages on their Zippos. For many, their inscriptions became their epitaphs. The insert is made from stainless steel and shaped in a die-cast machine. The inserts are transferred onto a conveyor belt. The flints, or spark wheels, are loaded into an assembly jig, followed by the cams, which will eventually act as a catch for the lighter lid. The cam is what keeps the Zippo lid shut. A wick is inserted and cut. Then, all the remaining elements of the insert are added. Finally, a flint screw is driven home to hold everything in place. The completed insert is press-fit into the outer case. The Zippo gets a once-over, a final buff, and it's good to go. For over 80 years, as a veteran of countless military theaters, over 500 million Zippos have been produced and have lit up the lives of 3 generations of servicemen and women. Coming up on Battle Factory. No matter where the fight takes you, these fuel containers can keep your motor running. And a simulated battleground prepares the soldier for the real thing. When it's cut and welded, this military-grade material will make one tough plastic bag. And it better be. It's going to carry 125,000 liters of diesel and jet fuel, enough to service tanks, jeeps, and planes, wherever the front line is drawn. In war, fuel becomes a target. How that fuel gets to the front line can make the difference between winning a battle and losing lives. In World War II, fuel was transported and stored in heavy metal barrels. When the barrels came under fire, they either exploded or all the fuel was lost. Now, there's a portable filling station that can gas up a tank in minutes and take a bullet without exploding. The mobile filling station breaks down into 2 parts: the fuel container and the pump. The military-strength pump will be housed in an aluminum cage to keep the machinery stable and protected. Once the cage is assembled, the pipes and hoses are fitted, the meter is attached, and the pump's engine is mounted into the frame. These military-strength pumps can fill a tank at up to an incredible 950 liters per minute. If this pump were used on an average car, it would likely take only 7 seconds to fill the tank. In the combat zone, fueling a tank has to happen fast, or they're sitting ducks. The fuel tank is not a conventional one, but a large foldable and reusable container. The bag is made from a top-secret formula of polyurethane and nylon. Each one is designed specifically for the type of fuel it's carrying and for where it will be deployed. And the shape is also not an accident. When a bomb goes off, it's the shock wave that can take out a vertical structure like a barrel instantly. But with these low-profile containers, the shock waves run into little resistance, so they roll right off the top of the container. In World War II, gasoline was stored in heavy metal barrels and pumped from large metal tanks. If the tank was pierced by a bullet, it had to be drained completely before it could be repaired with a welding torch. When these fuel containers come under fire, the hole can be plugged in seconds with a temporary screw plug, then permanently repaired with glue. To construct the fuel container, the sheets are joined together using radio frequency welding. Working like a microwave, it liquefies the top urethane coating from the inside out. The result is there's no longer a seam left. The pieces are bonded together at the molecular level. These seams will last for 10 years. There are two holes in the fuel container called flanges. One on top is used to pump fuel into the container, the other to pump it out. And the seal around those holes is critical. To make sure the fuel container is field ready, every seam, seal, and flange is tested. The bladder is overinflated with air, and a soapy liquid called leak tech is brushed on. If there's a leak, a bubble will form. An air leak here means a fuel leak in the combat zone. Thousands of dollars of fuel could be lost and put lives at risk. It passes the test and is ready for action. The container is then folded, loaded up, and prepped for travel. 6 of these mobile fueling stations can fit in an average shipping container. This is the equivalent of 8,700 metal barrels. In fact, Europe is still cleaning up the mess from World War II. Barrels are still being found today. Once it arrives on site, the folded container expands to 10.5 by 10.5 meters with a capacity of 125,000 liters of military-grade fuel. Each one holds enough diesel to gas up 107 Leopard 2 battle tanks. That's the equivalent of over 2,000 cars. Whatever the mission, these containers will fuel the fight. Coming up on Battle Factory, these special effect explosives mean gaining battlefield experience without losing your life. This aluminum bar is about to be transformed into a revolutionary training tool that could make the difference between life and death. Landmines and IEDs, or improvised explosive devices, are as lethal as they are terrifying. They've killed more than 3,000 troops and wounded 3,000 more since coalition forces landed in Iraq and Afghanistan in 2003. IEDs and landmines are often buried and triggered with a cell phone or remote control. Tough to spot and deadly. One wrong step could be your last. These surprise attacks cause panic and confusion. The first instinct is to freeze. But when you freeze, you become a target and a liability to your squad. In the past, it's been impossible to mentally prepare for these deadly threats without putting the soldier's life in danger. Now, a military simulation special effects company has created the ultimate training tool. When detonated, they unleash a sensory assault without causing injury. A soldier learns to handle the sounds and smoke of an IED blast while keeping his cool and carrying on with his mission. Explosion effect simulators break down into 3 parts: CO2 cartridges, the remote control, and the canisters that generate noise and smoke. Using precision craft and aluminum parts, assembly can begin. The first step is the burst disc, which seals the canister. This will house the special effects powder. It's locked into place with a robotic press. The components are pressure fit to complete the canister, and now work can begin on the remote detonation system. To replicate battlefield conditions, the explosion effect simulators have to be triggered from a distance. All the component parts of the remote detonator are soldered, tested, and fitted into a durable housing that can be stowed out of sight or buried underground. The detonator sends low-frequency pulses to the canister. It can receive a radio signal from up to almost a kilometer away, as long as there is a clear line of sight. The U.S. military has mocked up a number of Afghan villages to simulate the sights, sounds, and even the smells of a combat zone. Marines are subjected to immersive training scenarios, bombarded with the extreme mental and physical stresses of insurgent IEDs and street-level firefights. These high-stress simulations train the soldier to adjust fast and perform better in real-world situations. The trainer prepares for the field test by arming the explosive effect simulator. Each cylinder is filled with FX powder that will discharge a blast of smoke and a pressure cap that will produce an ear-splitting boom. CO2 cartridges are locked and loaded into the back of the canisters. On the training field, the explosion effect simulator is tethered to the receiver and hidden from sight. Anticipation and heightened response time can be the best weapons against an enemy when the rules of engagement don't apply. Learning to stay cool and maintain focus in this simulated attack psychologically prepares the soldier for the real thing. It could mean saving his own life or that of a buddy when he's in the chaos of battle.